So here I have question number 9, and I think in the previous lesson I had said question number 7, so that was an accident. It was question number 8. This one's question number 9, and here we have graphing y is equal to cosecant of x within this specified domain over here. Again, I think this is important, but you're using a similar process as we use for y is equal to secant of x. So the first step is to understand that this is y is equal to 1 divided by sine of x, right? Obviously, this is just the reciprocal of cosecant of x, right? So y is equal to 1 divided by sine of x is the same thing as cosecant of x. So we use the same concept and really find points where sine of x is 0 to determine where the asymptotes may be for cosecant of x. So let's just graph that quickly here. So here we have our coordinate plane, right? So we have our x-axis or y-axis, and so we have 0, pi over 2, right? Pi over 2, we have pi, we have 3 pi over 2, and we have 2 pi, right? So we have these values over here, and now again, I recommend that you graph the sine of x, your sine of x first, and it just makes it easier. So let's just do that quickly. Sine of 0 is 0, sine of pi over 2 is 1, and then sine of pi, right? That is 0 as well. Sine of 3 pi over 2, that is negative 1. And then sine of 2 pi is just 0. So we have something like that. Now clearly, where do we have sine being 0, right? So we know that sine of 0 is 0, sine of pi is 0, and sine of 2 pi is also 0. So those are the places where our asymptotes exist. And clearly at those points won't be a part of our domain, right? Those points will be excluded from our domain. So let's just do that. So we make an asymptote here. We have an asymptote at this point over here at pi, right? We have one at 2 pi, right? You can still just graph this, right? Again, because it just makes it easier for you to graph cosecant of x, right? Again, because those curves are just going to be bouncing off, right? Bouncing off those points, like for instance this point. So if we're graphing this, again, you want to see where it's actually bouncing. So at pi over 2, obviously it's going to be the same thing, because sine of pi over 2 is 1. Therefore cosecant of pi over 2, which is just a reciprocal, is 1 over 1. That's also 1. Obviously this point here is in common, but you want to say that your curve is bouncing off, right? It's bouncing off this. It's more like a reflection, I guess you could say. So your cosecant of x here would look something like that. And then over here, again, reflection type shape here, right? This one's an upside down U here, so again, this point will be in common. Again, the reason sine of 3 pi over 2 we know is negative 1, well, the reciprocal of that is also negative 1, right? And that makes sense. So these 2 points are common. And that helped us, right, graph these 2 points. So now we can erase, I can just erase the sine of x here. So we erased that. And we have our asymptotes here, right? So we clearly have it. Now for negative pi over 2, and we have negative pi, right? And then we have negative 3 pi over 2, and then we have negative 2 pi. So we have these points over here, right? And then again, using that same concept, we should understand that there will be an asymptote at negative pi. So we have an asymptote here, and then we also have an asymptote at negative 2 pi. At negative 2 pi, right? We have an asymptote there. And again, the reason is you think this as sine of pi, right? So we know that sine of negative pi is equal to negative sine of pi, right? And so what is sine of pi, right? We know that sine of pi is 0. Right, so if sine of pi is 0, the negative isn't doing much, right? Negative times 0 is still 0, right? And because that 0 is still there for cosecant of x, that means that there will still be an asymptote there. So really, for pi there was an asymptote, for 2 pi there was an asymptote. Therefore, there's also an asymptote for negative pi and for negative 2 pi because of this 0. This 0 still remains there in the denominator for cosecant of x. So we have our asymptotes there, and it's that same concept. If you were to, you continue making your sine graph, right, and then you making those reflections here, you will see that at -3 pi/2, you have the point 1. So we want to make something like, I can just erase this over here. So we would have something like this, right? And then at -pi/2, so we have -1 here, right? And then we have, again, it would not be, obviously would not be crossing the asymptotes, something like that. So we have this. So we have one curve here, we have one curve here again, this point, this point, this point over here, and then we have this point over here. So that's again just a sketch of how y is equal to cosecant effects may look like. Just important to understand that your asymptotes, -2 pi, 2 pi, negative pi, and pi here, right? And again, all you're really doing is, if you think about it, you have, if you were to, for instance, let me just draw y is equal to sine effects quickly, right? So you have something like that, you have something like that, and then you have something like that, right? And similarly, you can continue to draw y is equal to sine effects here. So if you continue, it looks something like, so we have something like that, right? And then continues to go like that. So you see here that clearly, well, this point over here it should be the same here, and that's why it's here. So when you draw that sine effects, really, you see wherever your curve starts changing, right? You see at this point the curve was going like this. Now it changes at this point. The curve was decreasing. Now it changes at this point, right? This is your sine effects. At that point, right, you will see that there's an upside down reflection for cosecant effects. So use that sine effects to help you graph y is equal to cosecant effects. And obviously do erase these dotted lines. And don't get confused, because that's just the one for sine of x. So our graph for cosecant effects really just has these u's and upside down u's. So now when we're talking about the domain and the ranges, right? So for here, x-intercept, there's none, right? Because it doesn't cross the x-axis, obviously. And then for y-intercept, there's none, again, because it doesn't cross the y-axis. Domain is a set of all real numbers, again, within that specified domain, such that x does not equal 0, pi, 2 pi, negative pi, and then -2 pi, again, because we see there are asymptotes here, right? And then our range will be similar to the one we had for secant effects, right? Here the range is y is greater than or equal to 1, or y is less than or equal to -1. So that's a graph for cosecant effects. So thanks for watching.